Hello and welcome to AP Environmental Science presentation of Chapter 8, Part 3. This section's on mining. It's presented by myself, Mrs. Gabriel, and the textbook authors Friedland and Relia. These are the goals that we're focusing on for the next few minutes, so make sure you revisit them at the end, and let's focus on trying to meet these. I want you to be able to explain how elements and minerals are extracted from the earth for human use, and I want you to be able to describe the impacts of mining on the environment, biodiversity, and human health. This is where I recommend you pause and you write down your predictions about what these are. So looking at this figure, rocks and minerals are used by humans as fossil fuels, building materials. We use them for developing roads, houses, and the list goes on and on. They all exist, though, in finite quantities. That means they will run out. Finite quantities will run out, but we depend on them. We really need them. In this section, we will discuss some rocks and minerals and how humans obtain them. We're also going to look at the effects of extraction on the environment and even on human health. This chart shows the abundance of elements in the crust. Notice that the most abundant is oxygen and then silicon. However, it's important to understand that proportions of these elements vary from location to location. Okay, now, these are some of the metals we like to extract for human use. How many years do we have left in our aluminum reserves? Correct. Only 2 in the US. How about copper, which we use for electrical wiring? Only 40 in the US. How about chromium? Iron for steel manufacturing, and the list goes on with this. Make sure that you understand these. When they run out, then what do? Do we buy them from other countries? Who will make a profit when we don't? Do we come up with alternative materials that we can do the same thing with? How do we find more places on our own territory? Well, environmental scientists and geologists use their skills and their knowledge to find locations where some of these very precious metals might be for us. And they figure out ways to manage their extraction, and now it's really important that we also consider their conservation. Ores, and you need to know these words, ores are concentrated accumulations of minerals from which economically valuable materials can be extracted. Ores are mostly valuable metals, but they could also be salts or sand. Metals conduct electricity and heat, and metals such as copper, nickel, and aluminum are highly desired for manufacturing. Metals are usually found geologically with other elements. Ores can form when magma comes into contact with water, creating a solution where metals precipitate. Some ores come from deposition of igneous rock. Some form in veins. Some ores, like bauxite, are found where intense chemical weathering occurred in tropical regions. Bauxite, by the way, is the ore for aluminum. And the tropical regions, that could be here right now, but maybe the plate had this particular location that we're on in a tropical region 100 million years ago. A reserve is the known quantity of a resource that can be economically recovered. That means recovered for money. Now, this table lists the estimated number of years remaining in supply, and this is assuming the rates of use don't change, that we don't suddenly need more nickel for some new invention. And the global supplies are also just estimates because private companies hold rights to keep the land information a secret, so we don't always know what they're up to. Okay, these are the types of mining, so take a look at this really carefully. It looks easier than it is. There are many steps involved in mining, from extraction to separation to further processing. 2 kinds of mining take place on land, and these are the ones that we're most concerned about for this chapter. What are they? Surface and subsurface mining. And they each have environmental, human, and social benefits, as well as environmental, human, and social costs. Now make sure you refer back to that picture so that you can remember the types of mining. Now this picture shows the life cycle of a metal resource. Each step in this process uses large amounts of energy and produces air and water pollution and huge amounts of crushed rock and other forms of solid waste. The lower the grade of the ore, the greater these environmental impacts. And notice that some of these arrows, like smelting to melting metal to conversion of product, can be recycled. That doesn't mean we do, though. Okay. Now, if you look at natural capital degradation as the title, look at what the subtitle is. These are extracting. These are all processes that have to do with getting our minerals from the earth to your table. And it's showing some harmful environmental effects of extracting, processing, and using non-renewable minerals and energy resources. The biggest environmental cost is the need for energy required to carry out each step. This causes additional pollution and it causes environmental degradation. Each one of the steps in mining requires the use of more energy, which makes a much bigger footprint. Now look at the environmental effects of just exploring and extracting on this chart. Just look for exploration, and extraction. Which one would bother you most? Without looking at the right column, can you guess an effect of transporting the mineral? And by an effect, I mean an environmental cost or an environmental disadvantage. Without looking at the right column, can you guess purifying it for use? Now check and compare your ideas. Okay. In the next few slides, I'm going to show you some examples of surface and subsurface mining. Make sure you refer to this table as you review each type. Come back to this table regularly. Notice that the table shows effects or impacts on a variety of important sustainability issues. So we're looking at air, water, soil, biodiversity, and humans. These are all things that we keep visiting in environmental science. Okay, so this slide is open pit mining. Open pit is just around the corner from us, actually at Vulcan Quarry. It's in Havre de Grace. It's on the bay. They have a hard igneous metamorphic stone. What we mine it for is we use that rock for roads, sidewalks, and building materials. And they literally crush it. It's nice and hard. It doesn't weather easily. And they crush it into smaller pieces. And then companies buy the rock material in order to make their mixes. Strip mining, on the other hand, is common for coal and for sand. Now, when they're done with this pit and the machines digging into this pit, the miners have to put the rock that they didn't use back into place. They used to just leave everything behind as is. All this leftover material is called mining spoils or tailings. Make sure you remember those terms, mining spoils and tailings. Okay, this is a picture that's showing more on strip mining. You can see the hills of rubble and all those hills, like a car could fit, on one of those hills. These are called spoil banks. And if you look at them, you can tell that they're on really steep slopes, and you can tell it's just kind of broken sediment. So you should have figured out that means they're very, very prone to erosion. Okay, this is another type of strip mining. It's just showing coal extraction. And notice the words for undisturbed land, overburden, the bench, and then what they're trying to extract is from the coal seam. And this is just a close-up view of the same image in hilly and mountainous terrain. Now you're looking at mountaintop removal. There's a lot of this in Virginia, and this causes acid deposition and acid slurries in the streams. We'll learn more about that soon. And then think about when people used to prospect out west and they looked for gold. This is a form of placer mining. So we look for metals and precious stones in river sediments. Prospectors may have become rich from this method at one time, and this shows one of their operations. And there's a lot of this still in developing countries. This type of mining contaminates large portions of rivers with sediments that they're mixing up and disturbing, and with a lot of chemicals. Sometimes there's toxic metals that are released, like mercury, which is used for finding gold and silver. And by the way, mercury is very harmful to living things, especially humans. Oops. Okay, now if you look at the picture on the right, there should be one old story from when you were younger that you're thinking of looking at that. You got it, Snow White. So yes, we still go deep underground like Snow White's little dwarves to extract valuable ore. It's dangerous and it's detrimental to human health and to the environment. And these are real photos of some of our subsurface mining. Now this is just another image showing you really what's happening in our subsurface mining. So go ahead and take a look at all of this while I explain it. You should recognize many of the terms by now. So first, find the vein. So the vein is obviously the material that's of economic value. The vein could be sedimentary formed or igneous formed material. It looks like this is a valuable deposit for this mining operation though. The outcrop above it is how the geologist was clued into its presence. Notice the cage or the elevator that brings the workers to the ore deposit. So they take an elevator down to all that stuff that's going on underground. Notice that some ore hasn't even been discovered yet, all the way to the bottom right. But the prospecting drill is due to find it soon. See the drill moving its way towards the undiscovered ore. All these holes are eventually left behind when they're done with their mining operation, just left behind. And they could create future problems as far as groundwater contamination or even collapsing of the surface up above. This is a very hazardous job. Groundwater could suddenly fill in while they're working there in the passageways, so they're always trying to pump the groundwater out. Gas leaks from earthen materials can spark from machines and cause explosions. Polluted air doesn't circulate out of there enough, so human respiratory systems can get distressed. Also, just like when we are mining for coal on the strip mines, we can get from this acid mine drainage. And this often occurs, harms the environment, and harms biodiversity. Oh, and here's just a thought. Do you think it's really, really cold at the deepest part of the mine? You know, where the guy is with the prospecting drill? Or do you think it's really hot? Good job, you're correct. It is really hot. Because the deeper you go, the closer you are to the center of the earth, and the closer you are to hot, hot magma. I think this is an awesome picture. Okay, so moving on to impacts of mining. You've learned about the impacts already a little, but we still do it. And fortunately, we now have some mining legislation to regulate mining processes. So the purpose for the laws vary. Some of the laws that you need to know about is the Mining Law of 1872. And this was passed to regulate the mining of silver, copper, and gold ore on federal lands. This is also known as the General Mining Act, and it allows people to exploit resources on federal lands. It was, yes, they could actually, we wanted them to go mining on federal lands, and it was actually in order to promote people to move out west, and it was not a law that was put into place to protect the environment. So then we have some more legislation. We have the Surface Mining Control and Reclamation Act of 1977. That's a biggie. And this regulates surface mining of coal, not all mining. It mandates that land be minimally disturbed during the mining process and has to be reclaimed after mining is complete. It does not regulate the mining practices, however, so we can still create a lot of environmental disasters. It's just requiring that you don't disturb the land so much. Reclamation is actually part of the land contract. Mining corporations must pay profits into a special escrow account every month. So part of their profit goes into a special account that's monitored by the government, and that guarantees that they're going to reclaim the land. And when the mining operation shuts down, if they go away with it, there's still money in that escrow account so that the government can make sure that the land is properly reclaimed. And this is the chart that you looked at earlier, so just pay attention to it again. So what are the effects of water from strip mining? Acid mine drainage, contamination through tailings, and contamination through tailings which could be minerals that are dangerous to human health. This is an example of strip mining in Colorado. They got coal from this particular mine. And then the next picture is showing you the reclamation of that same piece of land. So reclaiming it means to make it like it was or to make it better. Some quarries turn the land into a golf course. Some quarries will reclaim their land by turning it into a public recreational swimming pool, housing, or commercial development. They might make it open park space. They finish mining and they must clean up their mess. That's all you need to remember. They also have to make sure that the porosity of the water running underground is not going to be a future problem in the groundwater. So you see just, filled in rock and hills, and now grass is growing and new trees have been planted. But sometimes they have pipes underground and they put special layers of mixes of clay and of sand so that leftover materials that might have metals in it that are harmful to human health are not going to leach through into the groundwater. So the lesson learned should be that everything we use takes away from the earth. We need to think of how to minimize that. Developing new materials and recycling more will definitely cut down on that need for us to mine. And some of the ways to achieve more sustainable use of non-renewable mineral resources are listed below. Do you do any of these? Have you thought about any of this stuff? These are solutions. Okay, so that's the end of this presentation. Here were the goals. So we learned about mining. Do you understand the relevance of all these concepts in environmental science? Great. This is the end of the video lecture. I hope you learned enough to shrink your environmental footprint. Have a great day.